Hi, my name is Amy, and I'm a registered dietitian and a math tutor here on Wyzant. My specialty is in mathematics and nutrition and dietetics, as well as just helping people in general who need help with math problems. So, anyway, enough about me. Let's get to the problem. So, right here we have a classic rate times time equals distance problem. Hopefully, you picked up on that. The other part of it is unit conversions, which something that is really down my alley because in dietetics, healthcare, nursing, pharmacy, all those fields, you really need to be good at doing your unit conversions. Enough about that. Let's get back to the problem. Okay, so I'm just going to walk you through it and kind of give you some tips on what to do, kind of set yourself up to do for success in terms of doing these problems. So this is how I interpreted it. I think the problem was there was a little typo here. I think what this problem meant to say is that a runner completes a 10K to go get some groceries, and the trip took 42 minutes and 15 seconds. And it's asking what is the runner's average speed in miles per hour. So first thing I always tell people to do is, just a good idea, is always keep in mind when you get stuck, what is it I am asked to do? What is the end point, okay? And here, basically, we're asked, the answer is going to be, what is the runner's average speed in miles per hour? So what we need to do is basically find a rate in miles per hour, and that's we're going to find, at the end of the day, find out how fast you was going at in miles per hour on this trip to the grocery store. So to kind of help us out, I kind of gave you some things that kind of are important to know, and I'm going to give you a split screen here, and then I'm going to go right on the whiteboard as well, give you some tips, and then also do the work on the whiteboard. It just seems like the easiest way to do it here right now. So let's see here. Share screen. Gonna do that. Okay, so in order to solve this problem, some things that we're going to need is that, it's basically this equation. It's not going to go away. It's just a classic equation. Hopefully you picked up on it. This is a rate times time equals distance problem. So rate times time equals distance. Write that equation down. Another thing we need to do is basically make sure we do some unit conversions, and those conversions, we have to make sure that we have compatible units to do this problem. So, we can have a rate, a time, and a distance, any of those variables, but if they're not compatible, then, it doesn't really work so well. So, and then the other part of it is we're going to need to convert. Well, we're going to need know what the conversion factor is. We're going to need to know that 1 mile is equal to 1.696 kilometers. Of course, that doesn't do the math for us, but we're going to need to know that. It's kind of like a missing link here. The other thing we need to know is that there are 60 seconds in 1 minute, and that there are 60 minutes in an hour. Okay. Now, I'm going to go ahead and kind of walk you through it again, and step by step, how you go about the information, do the unit conversions, and ultimately solve the problem. So I'm going to go back to full video mode. Or just partial video mode, excuse me. We're going to go to partial video mode because full video mode is kind of stuck right now. So hopefully you can kind of see my board in back of me and what I've got here. So, all right. Now, so I kind of wrote some things here. And where are we trying to go? We're trying to get the rate, the time, and the distance. We have to do unit conversions, and we have to know what the average speed is at the end of the day in miles per hour. Now, the next thing I highly encourage you to do is kind of keep yourself organized, is write down not only where am I going, but let's write out what we do know, the information that we do know, and make a bulleted make a bulleted list, because I always like to say, kind of like when you make an outline before you write a paper. Making an outline before you do a math problem just makes sense. So, right, so we have here basically that we have, okay, it tells me that we have a distance here that they mentioned. It's 10 kilometers. And we have here a time. So that equals our distance in this formula. We have a time that's given, and that is 42 minutes, 15 seconds. 42 minutes, 15 seconds. And that's going to be equal to our time. That's our time. Now, we need to find that rate. Again, and that rate is going to be miles per hour. It's going to be our unit. Okay, so that's what we need to find. Okay, but before we do that, we got to put everything in the same units. Now, if you look at this, our final rate we need to get to, everything has to be in miles in hours, or miles per hours. So kilometers is really not going to cut it, okay? But the information that we need to do first is we need to convert everything into the proper units. So first thing I'm going to do here is take my 10 kilometers and I'm going to convert it to miles. Now, how do I do that? Well, I'm using some unit multipliers, and I think I gave you the conversion. The conversion factor is 1 mile is equivalent to 1.0696 something kilometers. We'll just say, let me just look here. Did I write that down? It's actually 1.60. 1.0606. 1.6. Oops, it's 1.6. 1.6. 0.93 kilometers. So we can just kind of round that off to 1.62 or 1.61. As we're not using like stick figures or something. So my conversion factor is how we're going to do that. Well, when we're doing conversion, the easiest way to do that is to say, what is it I'm trying to cross out? And kind of kilometers, and we need to get to miles. And the conversion factor here is, we said was in kilometers. So at 1.6096 kilometers, and then we said we know that 1 mile is equivalent to 1.6096 kilometers. So let's find out what that is, and that will give us our distance in miles. So then grab my calculator, and you take 10, you divide it, remember divide it by, it says 1, number 1, 10 divided by 1.60. So roughly you get 6.2 miles. That sounds about right, because I used to run the 10,000 meters in college, and that sounds about right in conversion to miles. So, just know that top of my head. Okay, so that's our distance in miles. That's going to be equal to our d. So we got that. We got our distance kind of figured out here. Got that converted. The next thing I need to figure out here is how do I gotta do something about this. And we can't have 42 minutes in 15 seconds. Because again, we're talking about miles per hour. And we also, the first thing we need to do here is get rid of the seconds. We need to convert things first, convert these into minutes. And then once we convert things into minutes, what is our next step? We need to convert those minutes into hours. So I wrote down the conversions there. And the simplest way to do that is take it and go, write down what we have here. So we have 42 minutes and 15 seconds. Okay. So first of all, actually, let's get rid of these seconds. Okay, so we have 42 minutes and then we have a fraction of a minute. Well, the easiest way to do that, I would say, is just hold on the 42 minutes. Let's convert these 15 seconds to minutes. So we have 15 seconds, okay? And I'm going to times it by the unit conversion factor, which is 60 seconds, right? So, so the 60 seconds in 1 minute. And that's how we're going to get that that kind of get that in terms of minutes and convert this 15 seconds into minutes. And then we're going to add it on to the other 42 minutes. So hopefully you probably don't even need your calculator to do that. But so when you divide 15 divided by 60, hopefully you got, and it's just late, so I'm going to do it anyway. So basically you should get 0.25. That should make sense because if you look at the clock, 15 seconds is about a fourth of an hour, and you get 0.25 minutes. But remember, that's going to go as part of this, so we're going to add that with the other 42 minutes, and we're going to get 42.25 minutes. So now we're talking about minutes. And make sure you cross that out so that you get your units correct. And by crossing things out, you're less likely to make a mistake and you kind of know where you're at, and you should end up with units where you're going. So we have this for distance. And now I have a time of 42 minutes. So, but we're not there yet. So, because we need to take this time of 42 minutes and 25 seconds, and we still need to convert it to hours. So, our conversion factor there is 60 minutes and 1 hour, correct? So, again, we're going to take 42.25 minutes, take what I know, and then I'm going to times by for 60 minutes and 1 hour. And what does that give me? All right, so then I do that math. So we crossed out the units. That's always a good sign. Should leave us with hours. Then 42.25 divided by 60. And that gives us, so I did 42 minutes, 60 minutes, and 1 hour. So I guess it's going to give us our time. So when you do that, you should get basically 0.704. Okay, that's kind of a fraction of an hour. So 0.70 hours. Hours makes sense because 45 minutes is not quite 60, or 45 is roughly 45 minutes would be about 75% of an hour. So does that make sense? Yes, I would say so. So 0.704 hours, that's going to be equals my time. Now, do we have everything in the same units, right? Okay, we have a time. We just did that. We have our time in hours. Check. We have our distance. We did that. We have a distance in miles. Yes. And my end rate that I need, as we talked about, is measured speed, and it's in miles per hour. Do we have that? I would say so. We can find it. Well, we don't have that yet, but we can find it because my units now are in miles and in hours. So all we have to do then is plug everything back into this rate times time equals distance problem up here equation and solve for our final rate. So I'm going to use red for this one. Okay. Just bring this screen down a little bit. There we go. So I'm going to rewrite it again, just kind of chug and plug. We have my rate, and my rate is what we're trying to find. So R times our time. And again, our time was here, 0.704 hours. And then equals our distance. And we said our distance is in miles. And that was this, our 6.21 miles. what were we trying to find? Our rate, again, in miles per hour. So all that's left to do is, okay, solve for R. So it's 0.704 hours. Come on. Just realized it's getting kind of late here. Okay, now times R equals 6.21 miles, and divide, right? Get R by itself, 4 hours, divided by 0.704 hours. Hopefully you can see that with the red marker. Sometimes that's harder to see. And now that crosses out. So that should give us a rate R. Should be, I'll do that. We do our math over here. We divide 6.2 divided by 704 here. And that gives us, the units in miles per hour. So when we divide the 6.2, get R by itself, 0.7. Let's see what we got. You're going to get 6.21. Okay, so I have a rate of 1.42 miles per hour. Not the fastest 10K runner in the world, but but you know, hey, they got there. All right, so 1.42 1 hour, so 1.42 miles per hour. Well, I shouldn't say not the fastest. I'm sorry, I wasn't thinking right. Actually, what was it? 42 minutes. That's actually not a bad 10K. That's pretty good actually. Um, I was thinking, never mind, but actually that's not a bad. That's actually not a bad time. Okay. Anyway, long story. So your answer, little side note, your rate should be 1.42 miles per hour. So does that make sense? Well, we can kind of also check it by putting it back in the equation. If you do that, you have 1.42, and then you times it by your time, which was in hours, which is 0.704, and hopefully that gives you 6.21, right? So that's how you would check it. Just put in 1.42 miles times our time, 0.704, and then we should get our distance should be 6.21 miles. Let's see if we get that. Times 0.0704. Oops, did I just okay, let's see here. Oops, did I just make okay, rate times time. Oops, I think I did something wrong there. Hours times point times distance 2 hours. Okay, so that issue here something like I got something is over 2 minutes to do. For some reason I'm thinking something is miles per hour. That's right. I'm just checking my answer here just to make sure. Hours, rate, average rate, times miles per hour. This one's here. We're not getting time. Rate 1.42. Okay. I made a mistake. I was going to say that didn't look right. Made a little bit of an arithmetic error. So that's why sometimes it helps to kind of check your answer because I know one. Okay, so how do I know that? So when I plugged it in, it isn't right. So, okay, I just did this last part here wrong. So that's okay. We can fix that. We'll go back and fix it. So that's why helping to check your answer helps. It made me realize I made a little bit of a arithmetic error. So, or algebraic error, I should say. So I'm just going to write this out a little bit neater. Again, so this, we're going to solve for r. And I need to solve for r on this side. So we have r equals, and then it is 0.704 hours to give it a rate. Let me just double check that again. Okay, so, all right, that sounds a little bit better then. Sorry, but it just kind of goes to show you that you should check your answers, plug them back in. So 8.82 miles per hour. Let's check them again then. So I have 8.82, that's why you check your answers if you can. It's rate, and then our time, again, I said was 0.704 hours. And then my distance, I said, should be 6.21. So let's check it again. So we had a rate of 8.82 miles per hour. And that's miles per hour. Okay, and then we're going to times it by 0.704. So this time I get 6.21 miles per hour. So hopefully you listened to the whole video because our answer, like I said, I noticed my own mistake. And how did I know that? Because when I plugged it back in, I didn't get 6.21 miles. But my answer, my final answer should be 8.82 miles per hour. Again, it's 8.82 miles per hour, and that is my average rate in this problem. Okay? Thank you for listening. If you have any questions, please let me know, and hopefully you'll listen to the whole video to the point where I checked my answer. Okay? There we go.